All right, welcome on in, everybody. So we are continuing with our discussion of factoring. So just kind of a heads up, remember, when we get through this chapter on factoring, there's going to be an exam, so it's close, right? So here's kind of the way I expect this to go. We might have to deviate from this a little bit depending on how long it takes us to get through certain things. But here's... Well, it's hard to say. So we're still going to have to be a little difficult. It depends, because I'm not exactly sure if this is going to take us... I kind of suspect it's going to take us 2 days to get through this part. So, well, it kind of depends where we get today. So I can probably give you a little bit more information at the end of class. But the idea is we're going to spend a little bit more time talking about factoring trinomials, and then we'll probably get into special factoring. Depending on how far we get into special factoring, means that the remaining material will either be covered in 1 or 2 class sessions. I'll have a better idea at the end of class today. So that means that the idea is we would finish up new material either Monday or Wednesday of next week. So whatever day we finish up new material, the next day would be a review day. You'd have a practice exam that you could work on. And then the next time that we, after that, you would have an exam that you're going to be working on. So I probably will forget because I'm so focused on the actual teaching. If somebody asks me at the end of class about the exam before I turn off the stream, then I can sort of recalculate where we're at, and I should be able to tell you what the time schedule for the exam is. But right now, it depends how far we get into the special factoring. There's definitely some explanation that needs to be done, so I don't want to rush through that, and it really depends how long that one's going to take. Okay, so just don't, it's not rude. Feel free to remind me when it sounds like I'm starting to wrap up class. Somebody throw into chat about the exam dates, and then that'll remind me to talk about it again, and then I should be able to tell you. Okay, so remember we are talking about factoring trinomials, which is where we left off. Now, hopefully, most of you are comfortable with factoring the basic trinomials, the easy ones where your lead coefficient is a 1. So the coefficient on the x squared is a 1. Those, usually people are fine with those. People almost never miss those on the test. Usually if someone does miss that, they probably miss basically the whole test because those are kind of the easier ones. The harder ones are the trinomials where the coefficient is not 1. So factoring trinomials for most people are both the easiest and the hardest problems of the whole exam. Certainly of the whole chapter, but for many people the whole exam. So make sure you don't ignore those ones where the coefficient is not equal to 1. So I showed you how to do it with the guess and check method at the end of last class, where basically what you do is you read the clues inside of the polynomial. You look at the signs, you figure out what your signs need to be inside the parentheses, and you're writing it down, right? I think people don't believe me, but literally, like, I'll have students where they ask me for help, and they have a blank page, and I say, okay, write the next step, and they write it. Okay, write the next step, write the next step, write the next step, and then they're done. And I didn't even help them with the math. All I told them was to write stuff on the paper, and they actually are able to do the whole thing. There's sort of this, I observe it all the time. There's this weird like roadblock in people's heads where they think they're going to do the problem in their head, and they don't understand why they can't do it. As soon as they start writing on the paper, it just flows out. It's because you're not meant to do a whole problem in your head. You're meant to do little pieces of it in your head. So write the stuff down. Right? Students don't believe me, but like I watch students just, okay, I just did it, and I didn't even help them, right? So what I'm going to do is show you another way of factoring trinomials where the lead coefficient is not 1. I don't care what method you use. On the test, it's not like I'm going to tell you a specific way to factor the problems. They're just going to say factor, and you have to factor them. Okay, so it's up to you. Some problems have more than one way that you can factor them. Some do not. So like difference of cubes, which we may or may not talk about towards the end of class, there's only one way you're factoring those, and that's with difference of cubes, right? Many of the factor by grouping problems, you're only going to factor them with factor by grouping. But some other problems, like the ones we're going to look at today, you can solve by guess and check trinomial method, or you can factor them with turning them into a factor by group problem. So it's whichever Whichever way works for you is what you should do. I mean, in mathematics, that's what it comes down to is if you have an people don't understand, a major chunk of doing well in mathematics is just your own personal organization. So if you have a way or a teacher taught you a way of organizing your work that works for you, go with it. Use that way, okay? I have some students that do almost every problem in this chapter with factor by grouping. Good for them. They tend to do really well on the exams. But then I have other students who use a variety of methods, and some of them do really well on the exams too. So it's just, you have to do enough of these problems on your own to figure out what works for you so that you can you can be successful, right? And a lot of that comes down to taking the time to do the homework and getting help when you need it and getting that experience with things. Oops, I'm disorganized in my own desk here. Let me clear a couple things out of my way. Okay. So where were we with trinomials? So let's just remember, because it was a few days ago. Oh, I got to make room here. I always forget to clean this part up before the next class, but easily fixed. Okay. So let's just remind ourselves how factor by grouping works. So I'm going to go back a couple sections, and we're going to redo a factor by grouping problem. So you go, oh, that's right. That's what he's talking about when he's saying factor by grouping. Now I remember, right? So let's look at one. So we want to factor. So we want to factor this. Okay, a couple things, and I think I didn't mention this last time. Sometimes you have to rearrange the terms in your factor by grouping. So sometimes you'll get one and you'll go, the factor by grouping doesn't seem to be working. What you want to do is rearrange the terms and see if there's a way that you can get it to work. Okay. So, but anyways, we look at this. The way that I recognize this problem has to be done with factor by grouping is because there are 4 terms and none of them can be combined. So that means it's not a trinomial. We can't use trinomial methods. There's no greatest common factor to factor out. Like, we don't have any other techniques for factoring this. So factor by grouping is the way we're going to factor this. And that's how you're going to recognize these. If you have a problem with 4 terms, they can't be combined. If it's factorable, factor by grouping is how you're going to do it, okay? So remember, what we do is we group the first terms and we take out the greatest common factor. Well, there's a y squared in both of these, so I'm going to take that out. Remember, we're not looking for the greatest common factor for the whole polynomial. We did that before this. That's another technique, factoring out the greatest common factor from everything. Here, by grouping, we're only looking for the greatest common factors in the groups. So this first group, they share a y squared, so we're going to factor that out, and that will leave me with a y plus 3. Oh, and I'm gonna do a step wrong here just because some people get tripped up, but I want you to be able to recognize what happens when you make this mistake that I'm about to make. Okay, so I look at these and I go, what can I factor out? I can factor out a 2, so I'm gonna make this plus 2, and when I divide a 2 out, I get what? Minus y minus 3. But notice how my factors don't match, because our next step should be to factor out the parentheses should match, and then that's the factor we're going to factor out. But my factors don't match. So sometimes what people do is they just sort of try to force something to work and go, I'm just going to pretend like these are the same. That's not good in mathematics. When something's not right, don't pretend like it's right. Try to figure out what happened, what went wrong, and then you can fix it. So by looking at this, I go, well, these factors are almost the same, but what they're different by a sign. You go, oh, instead of factoring out a 2, I should have factored out a negative 2. Oh, that's what I did wrong. So let's go back and fix that. We'll factor out a negative 2, making this y plus 3. And now all of a sudden it works. And you might go, well, what's the big difference? You just changed the signs, right? But this sign right here changed, and that's going to end up in our final factoring, so it will make a big difference, okay? Now we factor out the y plus 3. And then when we factor out the y plus 3, that leaves us a y squared from the first term and a -2 from the second term. So our final factoring should be y plus 3 times y squared minus 2. And that's how you factor it. That's the correct way to do it. So that's factor by grouping, right? It's nice. It's only 3 lines, and the first line is just the original problem. Now, the technique I'm about to show you with factor by grouping does take a couple extra steps, but it's not nearly as much as, like, you know, remember last time with the guess and check, we kind of saw for some of those problems, if you're guessing and checking and you're not real good at narrowing down the possibilities by reading the clues in the polynomial, you may end up doing guesses 5, 6, 7, 8 times. That's annoying. Anyone gets sick on their 8th try of trying to factor the same problem, right? That's not fun for anybody. So when we get to the trinomials that have coefficients, like where it looks like there's a lot of possibilities. Remember, we did some last time where the coefficients involved in the front term and the last term were prime. That one's pretty straightforward. You're only going to have to try a couple things. But when they start having lots of factors and you start getting into combinations of all these factors, it can be a lot of options. So let's figure out how to do some of these trinomial problems with using factor by grouping. You might go, well, wait, how would factor by grouping work if I had a trinomial? Because that's only 3 terms. Factor by grouping wouldn't work. You wouldn't have 2 groups. That's a very good observation. But we're going to fix that. In fact, that's where the actual work comes into these types of problems, is turning a trinomial into a 4-term polynomial. You have to do that strategically, but then once you do it, the whole problem just falls out with factor by grouping. That's why some people like it. They're like, all right, I have to do a little bit of math here, and then the problem just sort of finishes itself if you're good with factor by grouping. All right, let me find that problem I was looking for. Let's start with the simple one. So I know that most of you can look at this problem and go, oh, I can just, or some of you at least, will be able to look at this problem and go, I can just factor that one in my head. Right, I know you can. I'm starting off with a simple problem so that you can follow along my steps when it's simple, and then you can turn those problems into the more complicated ones. This is actually a study skill that a lot of students, they do the opposite. They'll look at a simple case, do it in their head, and then they'll ask, well, why can't I just do it in my head? Why are you making me do it this way? I'm making you do it this way because I want you to see the steps so that when you get to the harder problems you can't do in your head, you know what the steps are, right? That's a technique for when you get stuck in mathematics. Fall back to an easy problem, study the steps that you're taking, and then when you understand those steps better, try to apply it to your harder problem, right? That's one really good way to get through things. Okay, so oops, that should be an X. So yes, some of you may be able to factor this in your head. That's not the point of what we're looking at right now. The point is to go through the steps so I can show you how the factor by grouping works. Then we'll get into the harder problems, but you're going to be familiar with the steps because you just saw me do it on an easy problem. Okay, so don't compare like, well, why didn't we use the easy one? It's because we're trying to learn the procedure. Okay, so remember we have, let me write it up here. We have this general form for polynomials where we write them as ax squared plus bx plus c. You're going to do this next semester in intermediate algebra this is intermediate algebra. In a few weeks when we're doing the advanced quadratic chapter, when we do the quadratic formula, that's your a, b's, and c's, right? Many people remember, oh yeah, x equals negative b plus or minus square root of b squared minus 4ac all over 2a. But then you go, do you remember what a, b, and c are? And they go, I don't remember that. It's these coefficients in the quadratic. Okay, so some books call this the AC method because we want this a number and this c number. And some books just call it factoring trinomials by grouping. So it doesn't really matter what we call it, but it's important to know we need the coefficient up here and the coefficient back here. So the reason sometimes they call it the AC method is because we multiply those numbers together. So AC equals, So the coefficient, our A value is 1. Our C value is 15. Okay, so you whatever method you call it, you're gonna calculate that. You take the coefficient in front, multiply by the coefficient in back, and you get 15 is our answer. So now what you're gonna do is you're gonna ask yourself, what are the different ways that I can multiply numbers to get 15? All right, there's only two. It's either 15 and 1 or 5 and 3. And you want to pick the one that will give you this number in the middle. Okay, so let's see. With a 15 and a 1, can I add or subtract those to get an 8? No. With a 5 and a 3, can I get an 8? Yeah, we can definitely do that, right? So then that means we want to use 5 and 3. So we're going to use that 15 is equal to 5 times 3. So basically what we're going to do is we're going to rewrite this trinomial, but we're going to break up this 8x according to our work right here. We're going to break it up as a 5 and a 3. So this problem will become x squared plus 3x plus 5x plus 15. See how it's now a 4-term polynomial? That means that we can apply factor by grouping to it. Okay, and well, let me save that point that I was just about to make. I'll actually show you when we're done with this. Okay, so now I'm going to use factor by grouping just like we did. So we did this little bit of math to set up the problem, but now it's just like the problem we did a minute ago. So let's see, what can I factor out from the first bit? So I can factor out an x, giving me an x plus 3. Plus, I can factor out a 5 with an x plus 3. Look, now I have that shared binomial factor of x plus 3. So if I factor that out, I get x plus 3, x plus 5. And there we have the thing factored. Right? We can check that pretty easily. That's correct. That's the correct factoring. But we did it using the grouping method. We turned it into a factor by grouping problem. Now, would this one have been easier to just do with guess and check? Yeah, probably. But again, I'm trying to show you the procedure so that you understand the steps, because we're about to do some more complicated versions of this. Now, a question that you may ask, I get this sometimes, and is a very kind of shows you're paying attention. When this question gets asked, how did I know to make it 3x plus 5x and not 5x plus 3x? Right? What if I had done it that way? What would happen? Well, let's take a look. So let's just redo the problem where if I had written it as x squared plus 5x plus 3x plus 15. So in other words, the 8 would come from 5x plus 3x instead of the way we just did it where it came from the 3x plus 5x. Okay, so I go, all right, so from the first one, we're going to pull out an x, leaving me with an x plus 5. And then from the second one, I can't pull anything out. So it's like we're factoring out a 1. Oh, nope, I'm sorry. I looked at the wrong line. We can factor out a 3, can't we? Leaving us with an x plus 5. So look what happens. We just end up with the other factor if we do it the other way, giving us this time x plus 5 times x plus 3. That's great news, right? So oops, I don't have my line there. Line break. So look, we just got the factors, but in a different order. And as we know, the factors, factors are identical, but in a different order, it's the same thing. So it doesn't matter whether you make it 3x plus 5x or you make it 5x plus 3x, you're going to get to your answer either way. You're going to finish the problem either way. That's great. That means you don't have to, that's a step you don't have to worry about. All that you need to know is the 8x needs to be broken down into a 5x and a 3x. Okay, but remember, they have to be factors of the 15. Sometimes I see students where they kind of they forget this step about the 15. They forget the AC step, and they're like, well, what? Like they're trying to break down 8x as 4x plus 4x. They're like, well, that's the one I chose. Well, 4x and 4x, that doesn't come from our AC value. 4 times 4 is not 15. So you can't do that. You have to use the factors of 15, right, which you get from multiplying the a times the c. Okay, let's do a harder version. Let's do it down here. Okay, yeah, let's do this. Couldn't remember which one it was I wanted to do. Let's do this one. Okay, this one is slightly more complicated. Probably not going to do this one in your head. Maybe you can if you've been doing a lot of these. But probably this one's going to take a little bit of work to do. Okay, so our next step is to calculate that AC method. So here's our A is 10, and our C is -3. So AC equals, what, 10 times -3, which equals -30. So we want to start considering factors of -30. What are the different ways that I can multiply numbers together and get -30? Well, let's see. There's 30 and 1. There's 15 and 2. There's 6 and 5. There's 10 and 3. I think that's all of them. I think we got them all. So, and you know, some people need to write those factors down. They make a list. Okay, great, do that. If that helps you, again, it comes down to, I see so many students, the more they write on the paper, the better they do. So if writing those factors down works for you, do that. If you can do the factors in your head, great. But if you're having trouble with the factors, then write them down. All right. That's always kind of the clue. Should I be writing more down? Well, did you finish the problem correctly? No. Then write more stuff down. Right? Students go, oh, but sometimes I get it right. Okay, well then sometimes you don't have to write it all down. But once you reach that point where you have difficulty, write it on a piece of paper. Okay? Don't keep trying to just expect your brain is going to magically like figure it out. It's not going to. Write it down. Okay, so from the options we went through, actually, did I write that down right? Yeah, so let's see. So with 10 and 3, that's not going to work because, so you might go, well, 10 and 3, right? With 10 and 3, I can get 13, but be careful. It's 10 and -3. If I add 10 to -3, I get 7, not 13. So 10 and 3 is actually not correct. Okay, that's not how we're going to break it down. It doesn't work. What about 15 and 2? Well, if one of those is negative, we'd want what? +15 and -2? Yeah, that gives me 13. That works. So be careful. I see students that will look and go, oh, 10 and 3, 13? Okay, I'm good. And they move ahead, and then the problem doesn't work right. Just double check those signs, that your signs are correct. So for us, the correct breakdown is going to be that -30 is equal to, we want 15 and -2. 30 is 15 times -2. Okay, so that 15 and -2 informs me how I'm going to break down this middle term here. And you might be a little intimidated by the fact that there's two variables. Don't. They just do exactly what you'd expect them to do. It's not anything scary or complicated. You can almost pretend they're not there and then just fill them in at the end. Don't do that. But I mean, it's not going to change the procedure that we're doing. So let's see. Where am I? Oh, right. So this will become 10x squared. Now I'm breaking up the 13xy as 15xy minus 2y. So 15xy minus 2xy minus 3y squared. So notice that if I simplify this, oops, it's a typo here. What is it, a plus? Yeah, plus. Notice that if I simplify this, I get exactly what we started with, right? It shouldn't really change the polynomial to a different polynomial. This is the same polynomial, it's just written differently. Okay, 15xy minus 2xy gives us our 13xy, so we're still good. Now we're going to go ahead and use the factor by grouping. So I go in there, and I'm going to say, okay, what can I take out of that first group? I can take out a 5x, and that's going to leave me with 2x plus 3y. All right, from the second one, it looks like I probably want to take out a negative y, right? Negative y, leaving me with a 2x minus 3y. Oops, no, it's not. It's 2x plus 3y. There we go. Now our factors match. So we're all ready for the next step of factoring out the 2x plus 3y. So the 2x plus 3y gets factored out front. That leaves us with a 5x minus y. And if we multiply that out, remember, you can just always multiply these out to check your work, which is worth it on the test, right? In any individual problem can move your grade quite a bit on a test. It's worth taking an extra 10 seconds to check it before you put it into the answer. But for the sake of time, I'm going to cheat and just check the book. And yes, that is the correct factoring. Got that all correct. Okay, I didn't make any weird mistakes along the way. So this still might look kind of long, but this was better than 8 attempts at guess and check, in my opinion. Even better than 6 attempts at guess and check. We had a little bit of work here to play with this negative 30, figure out these factors, change the way the middle term is written, and then it's just factor by grouping. And you have to know factor by grouping anyways, because there's certain problems that can only be solved with factor by grouping, and they can be beneficial in the case like this where you're trying to solve certain types of trinomials. Okay? So that's how you do those. If you want to solve all your trinomials by guess and check, be my guest. Go ahead. No judgment, right? If you can factor them, you can factor them. That's a skill that you need to be good with going into your next math class, unless it's statistics, and then it's not as important. You don't really use factoring in there. But in that next math class, you're going to have to be able to factor. If you use trinomial factoring, use guess or factor by grouping, whatever. That's fine, as long as you can factor it, okay? Also the remainder of this course, not just next semester, but also until December. Okay, are we good with that? Let's move ahead then. So I've got, what, about 20 minutes to talk about formulas. Okay, we'll see how far we get. Okay, so there are certain problems that you need a formula to factor. There's only 3 of them. And the truth is there's 2 of them that you're probably not going to come up across very much in real life, and those are the cubes. I mean, the reality is, if it was up to me, we wouldn't even teach factoring cubes in this class, because, like, in my life, and I have a PhD in mathematics, I've never just had to, like, factor a difference of cubes anywhere. It seems to me like kind of a maybe a waste. I hate to call it a waste of time, but it seems like it's not really used all that much. However, I will say I have to teach it. It's literally on the list of things that I have to teach in this course. So we do have to cover it. Difference of squares is different. Difference of squares comes up in a number of different areas and is important. But the 2 cubes formulas, honestly, like, you'll need to know how to do it in your pre-calculus class, because they'll give you problems that have difference of cubes in it. But, you know, the old question of, like, am I ever going to use this in real life? Unless you're going into a science-based class, you're probably not. And, you know, I took a lot of science and math classes along the way, and I, you know, except for in math class, never had to actually do a difference of cubes. But the other factoring you do use in real life, like along the way, especially if you're going science or mathy type career. Okay, so the first one's called difference of squares. This formula is pretty easy, and my guess is that most of you will have it figured out by the time you leave today. You will understand what's going on. Is that the squares? Yeah, that's how you spell squares. Okay, so basically what it comes in, there's a pattern, right? So a lot of times when people first see this, they're like, why would that come up? There's a pattern that comes up in mathematics more often than you would expect. And it's where we take two things and we add them together, and we take those things and we subtract them, and then we multiply the two things that we get. So you multiply the sum times the difference. It's just this pattern that comes up frequently. When you think about it, you'd go, why would anyone ever use that? The answer is it comes up a lot. So just kind of trust me for now. You're going to see this pattern. We're going to see it when we try to rationalize denominators. We're going to see it when we try to deal with complex numbers. There's a number of different places where this pattern comes up and is actually really convenient. It does some nice cleaning up of the problem. Excuse me. It's just occurring to me. I didn't drink any water this morning, so my throat's getting dry. This pattern comes up. So it's just trust me for now. It's important. You're going to see it coming up later in your math classes. So let's derive this formula. So I've got two objects, and I want to take their sum, and I want to take their difference, and I want to multiply those things together. Okay, so we learned how FOIL works. This, if you just go through and FOIL this, you get x squared plus xy minus xy minus y squared. Okay, so all I did right there was FOIL. Nothing fancy. I just used FOIL. But look at these terms in the middle. Look how they cancel each other out. We have a plus xy and a minus xy. That means those terms just annihilate each other, basically. So this whole thing simplifies to x squared minus y squared, which is literally the name that we call it. It is a difference of squares, right? The two terms in this thing are squares. We're subtracting them. When we subtract things, we call it a difference. It's literally a difference of two squares. So hence the name, difference of squares. Okay? So difference of squares formula, basically what's going to happen is you're going to see problems that look like this, and you're going to have to recognize that the formula, the way it's factored, is this over here. It's where you take the difference times the sum. So whenever you're using a formula, write the formula down, right? It sounds like I'm a broken record telling people to write things down, but that's like half my job as a teacher, I feel like, is if I can just get people to write things down, all of a sudden they're like really good at math. Right? The problem is when they just try to like stare at the wall and do the problem that way. So write the formula. The formula is literally like your roadmap through the problem. I guess figuratively, not literally. It's figuratively your roadmap through the problem. It's your guide. It's going to guide you through how to do the problem. So watch how I do this. So let's do a problem here where it is let's do 16x squared minus 25 y squared. Okay, and I want to factor this. I want to factor 16x squared minus 25y squared. That's my goal. Okay, well, I'm going to use the difference of squares formula. So if I'm going to use a formula, I should write that formula down. You'll see what I'm going to do. I'm going to write the formula down, and I'm literally just going to write everything in the formula right below it. So the formula is indicating to me exactly what to write. It can't get much easier than that. So here's our formula, says that x squared minus y squared is equal to x plus y times x minus y. That's our formula, right? So in other words, we have to figure out what we square to get these values here, and those are the pieces we plug into the formula. So what do I square to get 16x squared? What number times itself, or what term times itself, gives us 16x squared? It's 4x, right? 4x times 4x is 16x squared. So we're going to put a 4x in here and a 4x in here. And we know we're going to have a plus and a minus. Okay, now we ask ourselves, what about that other term? What do I square to get 25y squared? 5y, right? 5y times 5y is 25y squared. So then we put in our 5y. And you can see how I'm literally just, whoops. Let me do it this way. You can see how the oops, I need an equal sign. You can see how I just used this formula as my roadmap, right? I say, okay, what's the thing I'm squaring to get the thing in front? 4x. Okay, I'm going to fill those in right here. What am I squaring to get this? 5y. I'm going to fill those in right here, and it looks just like the formula. Okay. Now, the truth is most of you are going to get so good with difference of squares you don't have to write the formula each time. I get that. But when it gets to difference of cubes, I highly recommend write the formula down and then just write below it what it is that you're working on. Like, just fill it in that way. It's going to make it easier. Okay? So that's how you do difference of squares problems. Some of you are not real familiar with your squares yet. You will be. You'll get real comfortable with squares. You'll get real comfortable with cubes. So, you know, sometimes I'll have a student that's like working for a long time. They're like, I don't know my cubes. I don't know my squares. Well, what you do is you just figure it out, right? Just try them. If you don't know if 49 is a perfect square, then just try some things. Well, let's see. What about 5 times 5 is 25? So that's not big enough. Okay, let's go bigger. 6 times 6 is 36. Okay, that's still too small. Let's go bigger. 7 times 7 is 49. Oh, that's it. And then you just got it, right? So that's what you want to do in math when you're not sure about something. Just try a few things and then, try them intelligently. Try them strategically so that you can move towards the goal that you want to get towards. So, if you don't know what the square root of 64 is, then you just play around with it. Well, that must be bigger than 7 because 7 times 7 is 49. So let's see. Oh, 8 times 8 is 64. There we go. Cubes you're probably even less familiar with, but just play around with them, right? 2 times 2 times 2 is 8. Oh, 8's a perfect cube. Some of you may or may not have known that. 27 is a perfect cube. 64 is a perfect cube. 125 is a perfect cube. Just play around with them, and you'll get more familiar with them. After you've done some of these homework problems, you're going to get used to it, and you go, oh, yeah, I did 8 a minute ago. Isn't that 2 cubed? Oh, yeah, I did 29. I think that's, or 27. I think that's 3 cubed. And you'll start to learn these, and they'll get quicker for you. Okay? With that said, so that was how you do difference of squares. Like I say, students pick that up pretty easily. Then we get into difference of cubes. So let's look at that. Difference of cubes is kind of the same thing. You're going to have a formula. You follow along the formula, but the good news is the formulas, they are complicated, but they are similar to each other. So if you spend it doesn't take that long. Spend a little bit of time learning the formulas, and you'll have it in no time. Okay, so let's see, 10 minutes. Is this possible? No, I can't do sum and difference of cubes in 10 minutes. So that's where we're going to pick up next time. Let me make a note in my book. All right, I've got a bookmark in my book. We're going to pick up with cubes next time. So what I'll talk about today at this point is the test. All right, I said I was going to revisit, talk about the test. So let's go back and take a look. Okay, I'm going to spend some time talking about special factoring, factoring strategies, solve equations by factoring. Okay, that's going to take 2 days. So next week, we will be finishing up 5.7, 5.8, and 5.9. So a week from today on Wednesday, we'll be finishing up 5.9, which is solve equations by factoring. The week after that, we will have the exam. So at the beginning part of the week, I will release a practice exam, and you'll work on that practice exam. You're actually gonna email me questions so that I'll know what to talk about when we have our in-class review. If no one sends me any questions, then we don't need a review, right? If you don't have any questions, there's nothing to talk about. Sometimes in a review, students expect that I'm just gonna get there and talk for an hour, but I don't know what you need to know, right? There's certain things that you may completely understand, and then other things I think you understand that you don't. So the review that we do will be student-driven based on the practice exam. So next week we'll finish up new material. If you're behind on your homework, now is a great time to get yourself caught up so you're not trying to do it last minute, which will keep you from studying for the exam. Get caught up on your homework. Feel free to work ahead and work on some of the stuff if you want. I feel pretty strongly that a good portion of you would be perfectly fine working ahead and getting some of this done early. And then you'll work on the practice test, and then you'll have a few days over which to take the test. But the test, you can't take the test over a few days. What will happen is you'll have like a 3 or 4 day period on when to take the test. Once you start the test, you'll have a few hours to finish it. I usually give quite a few hours so that like no one runs out of time, right? It's not really an issue. So, and if you're a student who the school has decided gets, if you've gone through, done the proper paperwork and the school gives you double time for tests, you're welcome to contact me, but I usually give like 4 or 5 hours for the test anyways, and it shouldn't take more than like an hour to do. But, I can give I can give extra time if you have the double time accommodation, we can arrange that. But like I say, I usually give a 4 or 5 hour window anyways for students to, once they start the test, they have hours to finish it, because I don't really believe in math being done like under a time crunch. It's never made sense to me. That's not how it works in real life. You're never going to be at a job doing some math that you need to do, and someone's standing there with like a stopwatch, like, you're not doing these fast enough, you need to move faster. That's not how it works. So I never understood making tests that way. So you'll have plenty of time to take the test. You can pick a day that you want it where you don't have kids asking you questions, and you don't have parents that need you to take them to the doctor. You don't have to go to work. Pick a time where you've got a good chunk of time where people are going to leave you be, and you can sit down and take that test so you can plan ahead. There's a question about when it is. Let me check a calendar here. Calendar. What is this, October? I think so. So, yes, so I will be releasing the practice exam on the 25th, or possibly before that. It's possible I'll release it at the end of next week, because I know some of you like to get a jump on things and work early on it. So I might release it at the end of next week. That'll give you some time to work on it and time to send me questions. And then we can spend the 2 days that week going over questions that you have. Again, if you don't send me questions, then I assume there's no point in having a review. So we'll go over that. So especially if you remind me on the 20th, then I can probably release that practice test like the 21st or 22nd or something like that. And then you'll have some time to work on that. And then later in that week, so it looks like it'll be probably around the 28th or 29th or something like that is when the actual test will get released. And then you can choose between the 28th and the 31st when you want to take the test. But once you start it, you've got a time limit to finish it. Okay, you don't have 4 days to take. You have 4 days over which you can choose to start the test, but you can't take 4 days to take the test, if that makes sense. If that doesn't make sense, ask, and I can make it more clear. I knew you meant October. That's right. Right, so 10/25. So hopefully I'll get it out a little bit earlier than that. I know there's a few people in the class that like to work ahead, and as a teacher, you want to make sure if you have people who are trying to work on the class, you want to make sure that that work is available to them. So I can, let's see. In addition to preparing for the test, will we go over rational expressions starting on 9/25? Let's see. Nope, rational expressions will all take place after the exam. So that's like November. Right. So in November, you'll have we'll start chapter 6 because we only have 3 chapters. I guess we have 4 chapters left, but yeah, we'll maybe only take a week or week and a half to cover chapter 6, so that's okay. So that'll all take place afterwards, and I may have to adjust due dates. That's fine. I'll push those due dates back if they're due, so don't worry about those. We'll take care of all of that on the after the exam. Okay. Oh, and then just be aware the way it works in Delta Math is the rules under which you take a test will be different than an assignment. So like right now with assignments, it gives you multiple attempts and stuff like that. It's not going to work that way on the test. It's just you'll go in, it'll give you a problem, you get one shot to answer the thing, and then you go from there, right? If I remember right, because I have to use the test settings. I haven't used it yet this semester, so I kind of forget off the top of my head, but we'll see when I set it up. Okay, so that's where we'll go from there. So you should have a pretty good idea about what our time frame is like, and then that'll give us the month of November and parts of December to get through stuff. We should be able to move through stuff pretty well. Okay. So I'm going to shut down the stream. If anyone wants to hop over into Zoom and talk to me about anything, then we can do that. Oh, so there's a question, but can't take the full test twice? No. So there is a retake, though. So if you totally bomb the test, no sweat. You can take the retake and just get your score back up where you want it to be. So it's really not a high-pressure thing. If you start studying now and you start preparing now, you should be fine when you take the test, and then you won't even have to take the retake. But if you do poorly on the test, no sweat. Just study a little more, take the retake. Okay? All right, thanks everybody. Yeah, I'll see you next time.